So, girls, do you want to watch a movie or something like that?
Sure, what do you want to watch?
We can watch a romantic comedy or something like that.
Yeah, or a documentary, whatever you guys want.
What about a movie on derivatives?
Derivatives?
Yes, of course!
Yeah, let's do it.
Perfect!
Venga, va.
A ver cómo...
Recall that the average rate of change equals the slope of the secant line, which measures the change in y over the change in x between 2 points, as seen in the graph. The average rate of change on interval x to x plus h equals f of x minus f of a all over x minus a. Unfortunately, not all functions in economics are linear, so we need to extend the definition of slope through the concept of the tangent. The slope of a curve at x equals a is the slope of the tangent line at that point, and this is a precise way of measuring the slope of a curve.
The derivative of f of x with respect to x is the function f prime of x and is defined as the following function. The derivative is the slope of the secant line when h approaches 0. Derivative is the slope at a point, instantaneous rate of change, and slope of the tangent line. Slope of a curve varies as we move along it, and so does its derivative.
So derivatives are very important since together with integrals they make up calculus, which applies to every branch of physical science, statistics, economics, and other fields wherever a problem can be mathematically modeled and an optimal solution is desired. It allows one to measure the change of something with respect to another variable. Marginal functions are a great example of how derivatives are used in economics. The first type is revenue and cost, where we approximate the change in total revenue or total cost when quantity increases by 1 unit. Marginal revenue is the derivative of total revenue, which equals the price times the quantity with respect to demand. So the change in total revenue over the change in quantity equals the marginal revenue. Marginal cost is the derivative of the total cost with respect to output, and this is the change in total cost over the change in quantity. Then we have production. Marginal product is the derivative of output with respect to labor, change in quantity over change in labor. Once the size of labor has reached a certain threshold level, marginal product of the labor will get smaller, this is the law of diminishing returns. Derivatives allow you to determine how much of a certain good you should be producing in order to maximize profit. Profit equals total revenue minus total cost. Maximizing profit involves taking the derivative. The derivative of price equals the marginal revenue minus the marginal cost. In the graph, we see an example of marginal cost where an increase in 1 extra unit produced increases the marginal cost by 1 item.
Rules of differentiation are used more commonly since they are a faster way of differentiating than using the definition of a derivative. Differentiation is the process of finding the derivative or rate of change of a function. First rule is the power rule, which goes x in the power of n equals n times x in the power of n minus 1. Example number 1. Find f prime of x if f of x equals 3x in the power of 3 plus 2x plus 10. Remember, constants differentiate to 0. Product rule is used to differentiate the product of two functions. You need to multiply each function by the derivative of the other and add them together. Find u, u prime, v, and v prime. Quotient rule is used to differentiate the quotient of two functions. Bottom times derivative on top minus top times derivative of bottom all over bottom squared. For the chain rule, you need to differentiate outer function and multiply it by the derivative of the inner function.
Quotient rule? What is that?
That's super scary.
Our next topic is higher order derivatives. Because the derivative of a function y equals f of x is itself a function, y prime equals f prime of x, you can take the derivative of f prime of x, which is generally referred to as the second derivative of f of x, and written as f double prime of x. We can keep on finding the third, fourth, and successive derivatives of f of x, called higher order derivatives of f of x. Example, find the first three derivatives of f of x. F of x equals 5x cubed plus 2x squared plus 5x plus 3. Finally, we will be discussing an example of derivatives that has to do with economics. If the production cost per day for some widget is given by C of x equals 2,500 plus 10x minus 0.01x squared, what is the marginal cost when x equals 200?
What do you want to do?
Still have no clue what's going on.
I do. I love math. Okay, I'm sorry, guys.
Oh.